All right, today we're going to tackle something that happens to, well, pretty much everyone. We're going to debug a broken Docker file. We're diving right into that rite of passage for any developer, the moment your first Docker container just fails. It's frustrating for sure, but trust me, it's one of the best ways to really get what's happening under the hood. So picture this. You've followed all the steps, you've written the commands, and you hit Docker run expecting a little bit of magic. And instead, nothing. Silence. The container just exited the second it started. So what do you do now? Well, let's walk through this exact problem together and turn this broken build into a brilliant running application. So, what are we trying to do here? Well, the goal is pretty straightforward. We've got a simple Python web app that works just fine on our local machine, and we want to package it up into a nice, portable, reliable Docker container that we can run literally anywhere. And here it is, our first crack at a Dockerfile. I mean, it looks pretty straightforward, right? It's basically the recipe for building our container. We're pulling in a base Python image, copying our code, installing dependencies. All the right ingredients seem to be there. Looks good to go. And the process itself is, textbook. Step 1, we write that Docker file, our set of instructions. Step 2, we use Docker build to create an image from that file. Think of it like a blueprint. And step 3, we use Docker run to launch a container from that blueprint. Simple enough. And this is where reality comes crashing down. Our expectation was a happy, running web server. What we got was exited 0 seconds ago. The container died the very instant it was born. And this, right here, is where our real detective work begins. Okay, time to put on our detective hats. The container isn't talking to us, so we have to go find out what its last words were. See, when a container fails this quickly and this silently, it almost always leaves a clue behind in its logs. Your first port of call, your absolute best friend in this situation, is the Docker logs command. It's kind of like the black box flight recorder for your container. Even after it's crashed, you can just give it the container's ID, and it'll spit out everything that was printed to the console right before it went down. And boom, there it is, our smoking gun right there in the logs. The error is crystal clear. Uvicorn command not found. So the container tried to run our web server using the uvicorn command, but it couldn't find it. The program just doesn't exist inside our container. Ah, the classic. The 5 most dangerous words in programming. But it works on my machine. And that's exactly why we use Docker, right? Your machine has years of stuff installed on it. The Docker container, on the other hand, is a completely clean, totally isolated environment. It only has what we explicitly told it to install in the Docker file and nothing more. And it turns out the real problem was hiding in plain sight. We had Uvicorn installed globally on our machine, so we just never noticed that we forgot to add it to our project's actual dependency list. So when Docker built the container, it installed all our listed dependencies. But since Uvicorn wasn't on the list, it never got installed. The fix seems easy, right? Just add it to the list. So we're feeling pretty good about ourselves. We add Uvicorn to our project file. We rebuild the image, we rerun the container, and nope, it fails. Again, exactly the same way. What's going on? Well, it turns out that first problem was actually masking a second, totally different issue. Okay, so the logs have gone silent. They're not giving us any more clues. This is when we need to pull out the secret weapon, getting an interactive shell inside the container. Using a command like this lets us pop open a terminal, go right inside the container's file system, and just poke around. We can see exactly what's in there and what's not. So we drop into that shell, and we try to run the app by hand, and bam, we hit the real error. Error, no module named Hello World. Okay, this is interesting. Our app can't find its own code. The files are there, we copy them, but something is wrong with the path. And here's the culprit. It's a subtle one, but it's so important. It all comes down to a little quirk in how the copy command works. We wrote copy/hello world/code, and we thought that would create a folder called Hello World inside the /code directory. But that's not what Docker did. Instead, it took all the contents from inside our local Hello World folder and dumped them directly into /code. The folder itself was never created in the container, which completely broke our application's path. All right, we've got our clues, we've identified our suspects. Now it's time to crack this case wide open and fix this thing for good. Let's apply what we learned and make this Dockerfile brilliant. So let's just lay it all out here. We had 2 totally different problems, right? The first one, unicorn command not found, that was just a missing dependency. The fix, add it to our project dependencies so it gets installed. The second one, no module named hello world, was that tricky copy command. The fix there is to be more specific and tell Docker to copy our folder into a new folder with the same name inside the container. And with those two small, precise changes in place, we rebuild the image one last time, hold our breath, run the container, and success. It's running, it's stable. Our web application is up and serving requests, perfectly containerized. We did it. So what have we learned here? What are the big takeaways you can use next time you're stuck? First, and most importantly, a container is not your machine. Be explicit about every single dependency. Second, Docker logs is always your first step. Third, when the logs fail you, don't be afraid to get a shell inside the container and look around for yourself. And finally, really take the time to understand the little details of commands like copy. You know, this whole process of assuming something will work, watching it fail, investigating why, and finally having that aha moment of discovery, that's what being a developer is all about, isn't it? It's not about never making mistakes. It's about getting really, really good at finding them. So I'll leave you with this. What's the most confusing bug you've ever had to fix? And what was that amazing moment when you finally cracked the case?